Now that we've completed the component configuration, let's create an experiment for the optimization model. So we're going to click on the Scenario tab in the top left corner. And when hovering over the scenario line, go to the ellipses and hover over to the right to add an experiment. Here we'll give it a unique code and name. So we'll call this EXP and a name of Training Experiment. Okay, now we're just going to save. And we've now created our experiment level, which we will double click to enter and reveal all of the accordions within the experiment level. So first, let's start with the optimization objective. The default objective is set to profit, but we'll just change this for organizational purposes to maximize profit. And therefore, the objective function will be in the general for profit, and the optimization type will be maximize. The objective function weight and sort order are only applicable for whenever you have multiple objectives, which you could add by clicking the button in the upper toolbar to add a secondary objective, where you could adjust your function weights and sort order accordingly. But for this tutorial, we'll stick with only having the one objective. So we'll delete this secondary one and save our maximum profit. Now that we've done that, let's move on to the financials accordion, starting with product costs. So in this menu, we'll start by adding a product cost group, which we'll name appropriately to product cost group. From here, we'll add a product with which we'll start with the WTI product, and we'll give it the full name of West Texas Intermediate. So within the product row, we can assign a product cost. So here, we'll give the product cost the name of WTI Index. The price type we'll leave at Index. The cost rule type we'll assign to Fixed with a cost of $66 per barrel of oil. And we'll save before we move on to a second product, which we'll do WCS, which is the Western Canadian Select. And again, we'll add a product cost. And for this one, we'll call it a WCS gap. And that's because we'll be changing the cost rule type to gap because this cost will be directly affected by the WTI index. So our reference product will be the WTI index. And it will be a relation of minus $26 from the fixed price of the WTI index in a currency of US dollars per barrel of oil. Now let's move on to the final two products, which will also be a gap rule type in reference to the WTI index. So we'll start with the CRW, which is the condensate blend. CRW gap. Cost rule type is a gap in reference to WTI index with a relation of minus 12 US dollars per barrel. And now let's move on to the final one. Add our product. The MSW is our last one, and it is the mixed blend add the product cost, MSW, gap. The cost rule type is a gap, reference to WTI with a cost of minus 15 US dollars per barrel. So now that we've assigned all of our product costs, let's move on to the exchange rate that we've now created with having all of our costs in US dollars and the rest of our configuration in Canadian dollars. So we're going to add an exchange rate group, which I guess we can just modify it slightly to exchange rate group. And from here, we'll add an exchange rate, which will be a US dollars to Canadian dollars. So our currency from will be US, exchanging to Canadian at an exchange rate of 1.3. So let's save and move on. The cost rules and product rules are functions that will be featured in a later tutorial. So for now, we're going to actually skip down to the constraints, starting with the site constraints. The constraints accordion allows users to add constraints or restrictions on the model. These can be physical restrictions of the facility, product quality requirements, or other business or facility limitations. So we're going to start with site constraints. So first we'll add a site constraint group, which we will appropriately name site constraint group. Next, we'll need to add a constrained site, which we will choose the blending terminal. And once selected, we'll move back over to the tree, where we will then add a site constraint. So for this constraint, we're actually going to assign a maximum flow rate that the blending terminal can handle. So we'll change the name to max flow rate, change the constraint type to flow, and set a maximum limit of 1500 meters cubed per second. Now we'll save this and move on to stream constraint. So the stream constraint table allows users to restrict or constrain parameters on the outlet streams. So first off, we're going to add a group, which will just take the zeros off this default title. And from here, we will add an outlet stream, which we will choose to be stream out, and we'll rename it to outlet stream. And going back to the tree, we will add an output stream constraint, which again, we'll just take off these zeros. And for the constraint type, we'll choose the density parameter. And we're going to set a min and a max value for the density. So our minimum density will be 800 kilograms per meter cube, and our max density will be 820 kilograms per meter cube. Now that we've finished with the basics of the experiment configuration, next tutorial we'll go over the plan accordion and configure some nominations as well as creating the run.